All right. So I hope this is being zoomed and everything. All right. Okay, the quiz. How did you do on the quiz? Subpar. Below average, you mean? Well, we'll see. Hopefully you're mistaken. All right. Rapid development of tolerance. What? You know, what's the answer? A, clockwise. It's the only thing that causes a clockwise hysteresis. As the concentration goes up, your effect goes up. And as the concentration is still going up, your effect starts going down, right? So clockwise. The slow distribution of a drug to a site of action would cause a counterclockwise. Everybody got these? Yay. Good. No, because extended release is because of just the release. It's not about going to an effect site. I'm sorry if that tricked you. I didn't mean it to, but yeah, that is slow release is slow releasing it into the systemic circulation, whereas the relationship between the concentration in the blood and the effect is going to have a lag if it has to go to an effect site. You see the difference, Eden? Because if you got that, other people are mixed up. So does that make that clear? If I would have said extended release product, not about the effect, okay? Does that, you won't miss that on a test then if I ask. It is tricky wording, no question. Who wrote this thing? A drug following a linear pharmacodynamic model. Remember, that's the most simplified model. We start with the sigmoid Emax and then our Emax, and then linear is when what? Well, it's when E is equal to Emax times concentration, C50 plus concentration, and the gamma is 1, right? So gamma is 1, and the concentrations that we achieve are much less than the C50, so this falls out of the equation, right? That's what makes it linear. So that's true. That's true. And the slope of the line describing E versus C is Emax over C50. This is all true, isn't it? All three of those conditions, true. You good? Everybody's good. Good, 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 good. Awesome. Given the following information, determine the C20. Now, is C20 an effect or a concentration? A concentration. What does C20 mean? The concentration where we're at 20% of our max. Yes? Everybody? Okay. And C80, same thing, only 80% of our max. For, oh boy, please round to the nearest whole milligram per liter because we know we're going to have concentrations here. So if it's gamma of 1 and Emax is 1 and our C50 is 60, we know we're in an Emax model. So our C50 is 60 milligrams per liter plus concentration. And what do we want to know? The effect at 20. Oh, I need my calculator. Well, do you guys have a calculator? Can you do this for me? It's 15. So you all know how to do these, right? You just need to practice them a couple times. Remember how to do the algebra. So C50 or C20 is 15. And what's C80? Like 240? All right. Is everybody good with these? Excellent. Drug whoosh follows the attached pharmacodynamic model. There is whoosh. The therapeutic range is between C20 and C80. So what's the therapeutic range? C20 is 10, C80 is 40. So we're between 10 and 40. Yes, everybody good with that? So the therapeutic range is between 10 to 40 milligrams per liter. And the half-life is 3 hours. What's the longest dosing interval possible? Well, we go 40 to 20, 20 to 10, it's 2 half-lives, yeah? Are you guys starting to think like this? I love it. I love it. Those of you that said no, you're going to start thinking like this, right? You could also say that concentration at time t is equal to our initial concentration EKT, and put in here, we want to know when it's going to be 10 when we start at 40, e to the negative k. What will the negative k be in this case? 0.693 over what? 3 hours. You understand what I'm doing here when I'm converting half-life to a k? Not particularly. So do you remember that k is equal to 0.693 half-life? So basically, I just took that 3 and put it in here, yeah? You good? Can I do what? Well, maybe, how about this? If I switch to here? Because maybe, the problem is when I feel that pen, sometimes I just messed it all up, to be honest with you, Olivia. So CT, can you see that? So what do we say? We want to know when we're going to get to 10, and we start at 40. E to the negative k, 0.693 over 3 hours. Okay, and then we're solving for t, aren't we? We want to know the time difference here. And so this is going to be 0.25 equals e to the negative 0.693 over 3t. Can someone tell me what the natural log of 0.25 is? You don't, well, you have to know this equation here. Then would you multiply that times 3 and divide it by 0.693? Same thing. It's easier to do the way I think about it, right? Go from 40 to 20 and 20 to 10, and it's 2 half-lives. But you can always figure this out if it's not that clean. And recognize this is just a rearrangement of your K equation. It's all the same equation. If new drug Shazam has a therapeutic range between C20 and C80 and the half-life is 8 hours, if the patient takes more than usual and has a resulting Cmax of 100 milligrams per liter, how many hours will it take until it reaches the high end of the therapeutic range? All right, the high end of the therapeutic range is C80. So C80 is 25. So we want to know when we're going to go from 100 to 50 to 25. Again, it's 2 half-lives, right? So how long is it going to take? 16 hours. And you could figure that out using this same approach too, couldn't you? You would put, I forget the numbers, 100 here and 25 here. List the circumstances that might cause a drug to exhibit counterclockwise hysteresis. Active metabolite. Effect site. Turnover. Excellent. Pharmacodynamics is the study of the relationship between the dose and the effect. False. It's between the concentration and effect, yeah? A concentration effect graph of a drug following a linear model of pharmacodynamics would have a y-intercept of 100. False, it's going to be 0, isn't it? All right, one more. What is going on here? Drug A and drug B act on the same drug receptor. Drug A has an Emax of 100, a C50 of 20, and a gamma of 3. Drug B has an Emax of 100, a C50 of 5. Which is more potent? What are we going to look at? The relative C50s? Oh, you had 40 and 5. Whatever the lower one is, right. I'm sorry, I must have copied the wrong question. Whatever the lower number is going to be the winner, yes? So I apologize, I got the wrong, but you got, so this got several variations of that question. Yes. Yeah. Something that describes. Okay, I'll give it consideration, Brady. So tomorrow we start bioavailability. Yes. Sure.